Sigmoid function. The sigmoid function or the logistic function, it's a mathematical function that produces an S-shaped curve. How does this function look like? It looks like this, okay? It is an S-shaped curve. This is widely used in statistics, artificial neural networks and logistic regression. In the next lecture, we'll be learning about logistic regression, and that is why we are covering sigmoid function here, okay? The speciality of the sigmoid function is that if you give any real valued number, it will map it to a value between 0 and 1. This is why sigmoid function is very useful. It is particularly useful for binary classifications because if you give any real valued number, it can map it to something between 0 and 1, a value between 0 and 1. So this can be interpreted as probabilities because probability should always lie between 0 and 1, right? So the output of the sigmoid function, it can be easily interpreted as probability. Let us understand how particularly this function is useful. First of all, what is the expression for this function? So this function, sigmoid function, denoted by sigma of x is equal to 1 by 1 plus e power minus x. This is the formula for sigmoid function. So keep this formula in mind. This is very important. Sigmoid function, sigma of x is 1 by 1 plus e power minus x. Let us understand how this function maps any real valued number into the interval 0 and 1. Okay, this is very important because as you see the applications of sigmoid function, let us say logistic regression or anything, if you know the logical conceptual understanding of how this is mapping to a value between 0 and 1, the whole idea would make a lot of sense to you. When you learn more techniques or concepts which have sigmoid function in it, the whole idea will start making more sense to you and it will become more interesting. Okay, let us understand this. How does it map any real valued number into a value between 0 and 1? So first of all, I'll tell you the speciality is that if you give any value of x which is greater than 0, it will map it to a value between 0.5 and 1. If you give anything less than 0, it will map into a value between 0 and 0.5. And if you give it exactly x is equal to 0, then the value will be 0.5. So this is especially useful for binary classification because right in the middle, when x is 0, the value is 0.5, which means equal probability. When the value is greater than 0, x is greater than 0, it is above 0.5 and below 1. So that means a higher probability. If x is less than 0, that means it is between 0 and 0.5. So let us see how these values are coming up, okay? In case if x is equal to 0, this function becomes 1 by 1 plus e power 0. What is e power 0? E power 0 is 1. So it is 1 by 1 plus 1. It becomes 1 by 2, which is 0.5. So when x is equal to 0, you already understood it is 0.5. I told you that when x is greater than 0, it goes above 0.5. And if x is less than 0, it comes below 0.5. How does that happen? Let us see from e power minus x. The graph of e power minus x, it looks like this. E power minus x graph, okay? Here, the e power minus x graph would look like this. That is, if the value is highly negative, e power minus x will be highly positive, a very large value. And if the value is highly positive, then e power minus x will be very close to 0 or 0. It will approach 0 as you increase the value more and more. This is how the graph of e power minus x look. Now let us come to sigmoid function, sigma of x, okay? When x is, let's say, a very large value, that is limit x tends to infinity. When the value of x is very large, very high value, then the sigmoid function's value can be found as limit x tends to infinity 1 by 1 plus e power minus x, right? And what did I tell you about e power minus x? When x tends to infinity, what happens to e power minus x? This is the graph of e power minus x, okay? So when x tends to infinity, e power minus x approaches 0, which means limit x tends to infinity e power minus x is 0. So this becomes 1 by 1 plus 0. That is 1 by 1, which is equal to 1, which means limit x tends to infinity. At limit x tends to infinity, sigmoid function gives the value 1. So as the value of x increases, sigmoid function approaches the value 1. This is proven. Now let us see what happens when x takes very smaller values, that is largely negative values. So if the value of x decreases, in that case it will be limit x tends to minus infinity sigmoid of x. Okay, the sigmoid of x is 1 by 1 plus e power minus x. Let us again go back to the graph of e power minus x. If the value of x tends to infinity, that minus infinity, that is, if x is taking very largely negative values, what happens to the value of e power minus x? It is going very high. The value of e power minus x is approaching infinity when x is approaching minus infinity. So this can be written as 1 by 1 plus infinity, that is 1 by infinity, which is 0. So what did you understand from this? As the value of x decreases, if x approaches minus infinity, the value of sigmoid function is approaching 0. So from the last two derivations, that limits that we have found, limit x tends to infinity and limit x tends to minus infinity, what did we understand? We understood that as the value of x decreases, sigmoid function, as the value of x decreases, sigmoid function approaches 0, and as the value of x increases, sigmoid function of x approaches 1. Now let us see how the graph of sigmoid function look like. So this is, let's say, this point is 0, this point is 1, and here it is 0.5. Okay, then the graph of sigmoid function, it will look like this. Initially, when the value of x is very small, it will be close to 0. It will come like this. It will increase. It will cross at 0.5. So at 0.5, the value will be, that is when the value of x is 0, the value of sigmoid function will be 0.5. Then it will go up and it will go like this and it will approach 1. So this is how the graph of sigmoid function look like. Okay, this is the graph of sigmoid function. So till this point it is clear for you. This is also called as logistic function because we will use it in logistic regression. Let us understand what are the specialities of this sigmoid function or the logistic function. Okay, so keep this graph in mind, also keep this function in mind. Okay, so the first speciality is that it is a S-shaped curve. Okay, S-shaped curve, that is the first speciality, and because of this S-shaped curve, it smoothly transitions from 0 to 1. So the value smoothly transition between 0 and 1. And what is the second speciality? Second speciality is that this shape is ideal for modeling probabilities and any sort of binary, that is for probabilities or binary outcomes. This is ideal. Why is it ideal? Because your probability should be between 0 and 1, and when it is in the middle, equal probability, it should be 0.5. All these are satisfied by the sigmoid function. So the main thing is that it gradually increases from 0 to 1, which is really helpful for finding probabilities. And the next thing, as we already discussed, is that output will always stay between 0 and 1. So restricting it between 0 and 1 helps us in finding it as a probability. And the next thing, fourth one is, I'll erase this. The fourth point, this is a very important point, that is, whenever you are using this function for, let's say, gradient descent or in any of the applications in machine learning, one major operation you always have to do is to find the derivative, sigma dash of x. You will have to take the derivative and equate it to 0 whenever you have to find the minimum of it, right? That's how you find the minimum. If you want to minimize this function, you will have to find the derivative. So in machine learning applications, especially if you're using gradient descent or you want to find minima, you have to differentiate it. So finding the derivative, This is a key operation in all these sort of applications. And this is where sigmoid function has the greatest positive. That is, it makes the calculation easier. What is the derivative of sigmoid function f? Sigmoid function, it can be expressed in terms of sigmoid function itself. That is the beauty of it. Derivative of sigmoid function is sigmoid of x into 1 minus sigmoid of x. So the derivative is purely in terms of the sigmoid function itself. So the derivative of sigmoid function is sigmoid function of x into 1 minus sigmoid function of x. And where is this useful? In optimization algorithms, right? In gradient descent and such places where you want derivative to be, calculation of derivative to be easier. So this makes your mathematics easy. That's it. The next speciality, it is symmetric about x is equal to 0. We already discussed this. That is, at x equal to 0, it will give 0.5. Below it, it approaches 0. Above it, it approaches 1. So it is symmetric around it. And the last one is that it is monotonically increasing. What is monotonically increasing? It means as the value of x increases, the value of function also increases. There is no point at which the function will come down. That is, if you see this graph, always if the value of x increases, the value of function also increases. So this is what is called as monotonically increasing. Whenever the value of x increases, value of sigmoid of x also increases. So these are the specialities because of which sigmoid function is particularly useful for logistic regression or any of the classification tasks. Okay.